problem statement reads, I have 2 children. One is a boy born on a Tuesday. What is a probability I have 2 boys? If you were to ask anyone on the street this question, they would most likely end up answering 1/2 along the premises that it doesn't matter that I had a boy who was first born on a Tuesday, or most of them might even try answering 1/7, trying to take an educated guess based on the days of the week, and they would use Tuesday for an example. However, neither of these answers are actually correct. And before we dive into the solution, let's explore another problem which is roughly similar, but will give us a basic idea of this paradox and phenomenon. And that problem is, I have 2 children. One is a boy. What is the probability both are boys? Now, as we talked about earlier, most people would just end up guessing it's 1/2, but that's not the case, because there are 4 cases that could happen. My first child could be a boy, the second child could be a boy, first child could be a boy, second child could be a girl, or a girl boy, or girl girl. But the thing is, I'm given that at least one of my children is a boy, so I know it can't be the girl girl case. So out of these 3 cases, there's only one scenario in which both of them are boys. So then there'd be a 1/3 probability for that. But there's also another way of looking at it. I can draw a box like this. For my 2 children, boy, girl, boy, girl. We can say this is the first child and this is the second child. It doesn't matter which one is which order. But I know that the 3 cases I have are this box, and this box, and it cannot be this box because this box is for 2 girls. And so in this case here, out of these 3 spots, I only have 1 spot with 2 B's, and that's 1/3. So that's a quick way of visualizing it, and we can see how that works. Now going back to the original problem, here's the reason why that's important. Because if we were to do that problem right before looking at this problem, then we would also assume it's 1/3. Because essentially, in this state of mind, we are given that one of the children is a boy, and we want the probability that both of them are boys. But in fact, the fact that the first boy, or rather one of the boys, is born on a Tuesday is actually very important, and it makes the answer significantly larger than we would expect. And instead of just listing all the possible cases, the nicest way to consider is the diagram we drew like we did in the previous problem. That's why I talked about drawing the diagram with the BG and then the BG on the other line to make sure that there's a graphic visualization, this geometric probability, which makes our life a lot easier. So let's construct that here. And so the important catch now here is that I have a boy, girl for my 4 possibilities, obviously. But now I have a 1 through 7, each representing the day the child was born. And for the sake of simplicity, let 1 be Monday, 2 be Tuesday, so on and so forth, so that 6 is Saturday and 7 is Sunday. And what we see here is our diagram looks a little bit more different, because I know for a fact that at least one of these children was born on Tuesday. So let's first assume that it's this child who's a boy born on a Tuesday. That means if this boy is born right here on that number 2, that means this B and G can be anything, because I know I'm guaranteed that one of the boys is born on a Tuesday. So it looks like a rectangle like that, of length 14 and of width simply just 1. And now I have to do this for this other case, considering that the second boy was perhaps the one born on Tuesday. So I have this right here. And this is also another horizontal rectangle. So my total possibilities is the area of this weird cross-looking figure, which is basically the intersection of 2 rectangles. And it's not too hard to find the area of this figure, because the area of this figure is simply, in fact, 7 plus 7. So this right here is 14. So 14 plus 14. But then there's this intersection right here, which is a 1 by 1 spot. This is assuming that both of them are boys and they're both born on Tuesday, minus 1. So there's 27 total possibilities. And I wanted to find the probability that they're both boys, which means it happens in this first square right here in the top. So that is just 7 plus 7. There's 7 plus that 7, minus 1 for this intersection right here. And so then for an answer, I get 13 over 27. Now that seems awfully odd, isn't it? Because this is nearly 1/2, which means it seems a little tricky and counterintuitive, which is the point of this problem, is that most people would guess 1/2, obviously out of luck, even though it's roughly close. But mathematicians who have seen the previous problem with the probability given that one of them is a boy, and to find the probability that they're both boys being 1/3, they would guess or approximate the answer to this problem would be roughly around 1/3, if not even smaller, because of the extra restricted condition that he was born on a Tuesday, which is one possibility out of 7 days in a week. So that's all there is to this problem. I hope you guys enjoyed. Please leave a comment down below, subscribe if you're new, and let us know what other videos you'd like to see in the future.